Is the screen visible? Wow.
Yes, sir. Yes, sir. It is visible.
Okay. So you can start.
Good. Yeah. Okay. So this defined at the N1, N2, N3, that's written on the that defines 64. N1 equal to 64, N2 equal to 64, and N3 is equal to 64. These are the box size. Okay. So we have three-dimensional box where the data has been saved. So okay, and mm is the number of particles in that box. So it has 32,768 particles. And that LL is the grid size. And this VHH, yeah, this is the Hubble constant, uncertainty in the Hubble constant. So, and omega matter, omega lambda. So these things are cosmology. So if you look over that PPT, so they have got this number. We have to put this numbers, these values to the numbers. And then n step is not needed actually. It's okay. And epsilon 1 is that just that resolution. So these are the functions. So near float HF, FF, these are the functions. So if you look up the formula, so okay. So the first step, what we have to do is convert that whole thing, whole of that our particle positions into density. So that is done by CIC. CIC float. This function will convert the particle position into density, and that code has been written at the last. Actually, if you go down, then you'll find that code. So I'll just give a brief discussion about the code. Then after converting the density, then we have got the phi, which is related to that del square phi equal to 4 pi rho g. So this get phi, this will solve that equation del square phi in the Fourier space. For that, we require Fourier transform. So that will be just multiplied with the green function. So that will, then the next step is up initialize V. So after we solve the equation, then we'll have got that V initialization. So velocity will give velocity to the particles, initial velocity. And the next function will update the velocity for a particular, actually we have dA, so this scale length. So this will update the velocity to using this leapfrog method. And after that updating, then we'll update the position. So what will be the new position of that particle? Until the final step is reached. So this function is the main important function, and these are the related function. So above there is Q trap and other function. So these are your this Q trap and our trapezoidal solution of the integration using trapezoidal function, trapezoidal method. So Q trap above all these functions. Okay. So we can start writing the code. So first step, what you have to do? So you have to read the data from that file. Okay. So I think that do you have this output? Do you have all these files? Output.gel.dat.
Wait a second.
Hello.
Yes, sir.
Yeah, did he send you that file yesterday on last day?
No, sir. Like only he sent the FFTW, but since that was not working, we tried to abandon that, like not to go with.
Okay.
He didn't send us.
Yeah, let me send you that file also. So that's the input file from gel to which approximation. So
Yes, sir.
I'll send you. So that has got particle positions x, y, z, then the initial velocity vx, vy, vz. So we got 6 columns on that in that file. So if you look over that starting this allocation of the array, so after that it's allocated the 2D array. So I think you know this scallop malloc data structure in C, dynamic memory allocation. Okay, so I have sent you another file. Uh, just share that file with everyone.
Yes, sir.
So is this that file?
Yeah.
Can you see your text editor window?
Yeah, so this is the file. So the first 3 columns are x, y, z, and the second 3 columns are vx, vy, vz. Okay, so this contains around 32,000 lines. So you can open a GNU plot.
Yes.
In GNU plot, just type splot. Just change the directory after that slide.
Yes, sir. Just a second.
Yeah. So I'll
I'm
just
running
write
it.
the command in that chat window.
Yes, sir. Sure.
So don't write GNU plot, just open GNU plot. After that, just write SP, then space output dot gel dot dat in the quotation, then space U space 1:2:3 space W space D.
Okay, sir. Just a second.
First, change the directory in which you have kept the file.
Yes, sir.
You can share that plot also.
Yes, sir. Sir, I'm unable to change the directory, sir.
Okay.
Uh,
Anyone
the
can see
C-
that.
Yeah, I mean, it's a CD command, right?
Yeah, CD then full path name, or you can go to
Yeah,
the
yeah.
top part,
Yeah.
this file and change.
It's giving invalid character error.
It's giving incorrect means you can't change the directory or something.
Yeah, just a second. I'm sharing my GNU plot window also.
Yeah.
Yeah, can you see the GNU plot window, sir?
Yeah.
It's
Then,
giving error,
just
yeah.
you have to put code.
Okay, codes. Yeah.
Yeah, actually, better go to file.
Yeah, I think. Wait, just a second, sir. Yeah, can you?
Yeah, actually, there's one axis is X axis, Y axis, and Z axis. So you have got the 3 dimension. You can rotate that file. Rotate it.
Yes, just a second.
Okay. So this is a box. Consists of all the particles inside that. Okay, so this is the input file that is generated using Geldovic approximation. So it has got initial position and initial velocity, which we require for the n-body simulation for evolving. So the first part is to read that file. So this has been written actually. You can quit that.
Yeah. Yes, sir. Is my dev C++ visible? I think I.
Yeah.
Yes.
So this RRA and VVA. So we have allocated the array. Array allocation has been done. So this is 2D array. So it will have it will have rows with 3 columns. So 3 for the position and 3 for the velocities. So next is we are reading the file output.zel.dat. Okay. So R refers to read file. So if you write W, then it's write file. So R is reading file. So it's reading the 3 columns. So it's simple like as we do in C. Okay, so this part reads the file. Okay, so next part is that we have convert that this is a position file. So we have to convert the position into the density field. So this function does that. This function set up the memory for that. This setting up memory for row. So this will set up the memory, initial memory for that row. How much memory is needed? So it will be around n1 into n2 into n3. So 3 dimension, 3 boxes. So it will set up that. After that, we'll do the CIC that I've told. This converting that into density field is done by this. And then the next function will compute the potential around each gate point. So phi is potential, gravitational potential. So, and the next part is this update of the initialized V and update of the V, and then we'll update the position. And we'll change the position. So this function. So we'll repeat that for in the next part. Go down little. Yeah. So we'll do this for until we reach that A final. So A final is that we have taken as input as a scan. So if you go up, we'll see that go little below. Yeah, we have said that A equal to 0.1 and A delta A equal to 0.1 and A final equal to 1. So it will go 0.1 steps for the final output. You can go down. Okay, so these steps will repeat itself up till we reach A final. And this, if delta A is greater than 0, this has been done. Suppose that we start with A initial to be 0.1 and this or delta A is equal to 0.3. So we will never reach that A final to be 1. So we'll reach up to 1.99. A final to be 0.99. So that has been taken care of, so that A final is 1. That has been taken care of from this function, this last part. Yeah. So that will give up to A final equal to 1. So this will give the final position. So this is what we have to do. There is nothing else. After that, we write the output. So output, this is done in output.find.dat, pin.dat, and this second output.xy. So it stores only output of the 2 grid point, one slice. It stores the output of one slice so that it will be easier for us to visualize the plot. And instead of 3-dimensional plot, we'll visualize the 2-dimensional plot. So that's all in this coding part. So this output.pin.dat stores that output of that all the files, X, V, and this. Okay. So I think that you can write this part easily without taking any help. So just go down. Let's discuss that all the other functions. So these are allocating that 3D function, 3D array. So for the timing, since FFTW is not working, so we'll check with this. I've sent you a book, that numerical recipe in C. So go to that chapter, vast Fourier transform, and there is a function called RFFT3. go down. Yeah. Okay, so first we'll denote this, allocate the memory of that row, the density field. So it will be 3 grid spacing, so N1, N2, and N3. So it's N1 into N2 into N3. So just forget this allocate FFTW real. So since we will not deal with FFTW, so just we have RO, then so it will be like this RO. So we have 3. So it will be 64, 64, 64. So this will be our, so it will be 60, not 64, 66. Because of padding in the 2 Fourier transform, okay? So this will be our initialization of this. Ajay, can you view that RO that I have written?
Yeah, yes.
Yes, sir. Yes, sir.
Okay. So this will be our arrow, this RO, this density. Then actually we don't have this part. So this is the normalization we'll be having, and rho B inverse will be having. So this function is needed for the CIC. That CIC function, this part is needed. Okay. So go. Can you move up? So this is the CIC. So as I told you, so in the last class, so we have this grid point. So we'll be having 3-dimensional grid point. So suppose this is the point. So we'll distribute the density field this to this nearby grid points. Okay, and this has been done for all the particles. So this function takes care of that. So you can just copy paste this function. So it will work. So like this is a contribution of XYZ, XYZ. ABC means XYZ. Okay. This go up. Yeah, this line. So what it does, it's just multiply the each grid point with the weight into this R inverse that we have discussed, described above. This in setting up the memory for row, this part. So this is multiplied with weight. So at each weight is different for this all the 4 grid points. So the here weight is different, here weight is different, here weight is different, and here weight is different. So it multiplied with the weight. So this gives the, by this method we can distribute the particle positions into the grid point. So this method is cloud in cell method. So this is called cloud in cell method. Okay. So I think that if you remember in that PPT, actually I've discussed all this. So it takes care of like if this is X distance, so it will, the contribution of this comes to be 1 minus X. And if it's Y from that, so into 1 minus Y, like into 1 minus Z. So W will be 1 minus X, 1 minus Y, 1 minus Z, this one. Okay. You can copy paste it in your code, so it will work. So let's go. Yeah, this part is little bit tricky for you. Have you done FFTW? Mane, a fast Fourier transform?
So we have done it in the curriculum.
Yeah, coding part.
No,
No,
sir.
sir.
Okay, so uh, we have got two methods of doing that. So one method is that we just copy paste from the book numerical recipe. So there is a fast Fourier transform chapter 12 or 13, I think, something like that. We can copy paste from that, or we can write our own code, this Fourier transform code by ourselves. So it's better to copy paste from that numerical recipe book. Okay, so what it do? It's from this is the suppose this is the real space, so it converts to Fourier space. So in real space, del square phi is there, but when you convert to Fourier space, that will be equal to k square this phi Fourier. Okay, so then it is easy that del square phi equal to something. Suppose something 4 pi rho. So this is the so in Fourier space it will be something like this. For that will be something in the Fourier space of the right side. So then we can write phi equal to this a by k square. So instead of k square, we will having this sine square kx ky kz. That this part will be same. Okay, so just we have to use RF50W3 to convert that data into Fourier space, and then from the Fourier space, this operation will occur. This will be same as this code and that F50W code. After that, we have to transform back this to real space. So
Should I share the PDF, sir? Numerical recipe?
yeah,
Okay, sir.
yeah. Go to I don't remember the page. Just go down.
Is this one?
This Fourier, no, not this one. Go down.
Okay, sir.
Yeah, wait. लिटिल डब, नहीं उस फंक्शन का नाम देखना है। हाँ रियल एफ टी और नीचे नहीं और नीचे और नीचे और नीचे हाँ नीचे हाँ इसके ये वाला जो आ रहा है उसमें
Okay, sir. Just a second. ये वाला.
yeah this one.
Okay, sir.
Yeah, so it's Elena real RL FT3. So we have to use this function. So this is the input data that in our case RO. Okay. And this is the two-dimensional array that will return by that FFTW. This will and they are given the description. So N1, N2, and NN1, NN2, NN3 is N1, N2, N3 in our case. And this I sign gives that for Fourier transform it's 1 and for inverse Fourier transform it's -1. Okay. So in our case it will be 1 starting. That I sign will be 1. So we have to only define this. So you have to copy paste this in your copy in your node, not copy in this file, so that we can use that. So it requires another function called Fourier n. So it's a previous function, so we have to copy that also.
Is it this one, sir?
Just previous to this. Yeah, this previous to this. This Fourier founded. This function.
Yeah, yes.
Just check if it's required some other function or no. I don't think so.
No, sir. Even I don't think that it requires any other.
Yeah. You can remove that unwanted function like n error check and other things. So that will be easier for you. Okay, so we have to do that. So previously, let's discuss the other part of the code. So after that, you can copy paste. We can help each other.
Okay, yes.
Okay. So this function, what does this? It's calculate the phi. So this function only calculate phi from the gravitational potential. Phi from this. From this, it calculate phi. Okay, so this function does only this thing. So go down. Yeah. So here we have to initialize it initialize after calculating phi. So it initialize the velocity of that particle. So from phi it can calculate the grad phi. So this coefficient is that cof is that coefficient. So I think that you have seen that there you have got this function hf and ff. So they have written in the last to calculate. So this is the only cosmology it includes. Others are not cosmology. They are only just evolve. So this part makes it different from different. So this is like if you want to use the 10 body simulation for condensed matter, so this part will be different. So they could have some different coefficient or something, some different functions. Other process and everything will be same. So that part like solving wells, updating the velocity, solving that particle position. So that will be same. So this will be different only. Okay. So you can go down. Down. So that initialization, and they have this part, this function update that so it's just updated that it's calculate the grad phi and update find that like we find that this simple kinematics is okay. So this equation, so we update the velocity. So this is the initial velocity that we have got from the previous function. Acceleration is bit calculated using grad phi. This calculate the force and the divide by mass will give the acceleration. And instead of time t, we have taken dA. That's that change in that interval of the expanding parameter, expanding factor. So it's a scale factor also. Its name. So this dA is the expanding parameter, and this we have calculated phi. So here we'll calculate that grad phi and then update that velocity. So you can easily use this function also. So it does not require any Fourier transform or something. Okay. So just go up. So this is the what we have done. So wait. This is our initial velocity. This is the acceleration, and this is the change in time. So instead of time, we have converted the equation into change in this parameter. So del A. So just V equal to U plus AT. This A is grad phi. Okay. So in the final function, we just updated the x based on that equation. Just go up, go down. Yeah, wait. Just little up. Wait. So here, like so. Little up. Up. Oh, wait. So this calculated the final position of that by updating the velocity. So we have like x equal to x0 plus ut so this is the change in position. So this just updated the position. Okay, this function, and this is the boundary conditions, periodic boundary conditions. So boundary condition is like, suppose that particle is here in the corner. So if we update that, then it will go out of the boundary. So what we does? So instead of going out, it comes back from here. Something like okay. Suppose that suppose the boundary is 0. This is 0. This is suppose 10. After updating, the new position becomes 11. So what it will do? It will come back to 1. So this line takes care of this periodic boundary conditions. Just go up, go down. Yeah. So HF and FF, these are the function needed for calculating this coefficient. So this HF, then FF. For FF, we have got this integral. So this function calculate this. So this calculate using trapezoidal method. So okay. So this is what the all code is about. So most of the function has been written. So only one function you have to change using Fourier transform. So can we try it out now?
Yeah, sir, I'll try copy pasting it.
Just share that gel dot dat my output dot gel dot dat to everybody.
Yeah, sir, just a second.
Yeah. So how to remove all this? Right.
Is the dat file visible, sir?
Yeah. Just close this dat file. It's not needed now. Share means just send to everybody. Send the file to everybody.
Sir, how was it that file created?
Dat file has been created using Geldovich approximation. That last slide of the PDF PPT. So what we do is we assign a particle at each grid point. Then we give the amplitude and then random phase to the each particle, each grid point, so that we can calculate that phi, and by same procedure we solve this and find that.
Dear participants, like kindly check your email. We have sent the files to you via email.
Which email actually?
Sir, they have registered in an email, so we have sent the using an email ID. So to that email we have
Okay,
sent.
sure. अच्छा आप
Sir, what about this function here? What NR error?
just remove that. We don't require that.
Okay, yes.
Even write a error like inner error equal to some text error here or something like that.
Yes.
Just
Is
add
it?
that function in the C.
Yes, sir. I didn't get it.
There is a function which find the error.
Okay, sir. So it's not needed now.
No, it's not needed. Just check.
Okay, sir. Yeah. And shall I remove this? Include RF50W.
Yeah. Then go to this setting up memory for row.
Sir.
Setting up memory for row. This
Yeah, yes, sir.
so you have to remove this.
What shall I change here?
Actually, just write calloc or malloc.
Sir, I didn't get it.
Just write this calloc. Calloc. Do you know calloc function?
No, sir. Okay. Yeah. Allocation. Yeah.
Dynamic memory allocation.
Yeah. Yes, sir. Got it.
Yeah.
Where
Just
actually?
just float something. Just remove this one.
Which one?
Arrow equal to this allocate. You don't have to
This
write
one?
allocate.
Okay. Yes.
Acha, can you write a function to allocate 3D array?
No, sir.
Malloc, calloc.
No. Never tried that one. Not sure about it.
Acha, just do one thing. Go to the previous function, this F50W real.
Okay, sir. Yeah.
There just write instead of F50W real, just type double.
Here.
Double a float. Remove this F50W real.
Yes. This whole line.
No, not just real up to real.
Yeah. Yes.
Okay, so In A50W, instead of A50W real, just type float everywhere
Yeah, yes, sir.
in this whole function.
Okay, sir. Yeah. Yeah, done, sir.
Yeah. So that will take care of this.
Okay,
Then
sir.
remove arrow, P arrow and this Q arrow.
Okay, sir. So then remove to 2.
Yeah.
Yeah, yes, sir.
So actually, this is the and just go to arrow where we have defined arrow upwards. File type. Yeah, yeah. Just up.
Ah, yeah,
Ah,
yeah. Okay, I
just
should change it to
float
float. Yes.
and remove this too.
Okay, sir.
Okay. So
Yeah.
and here also we have to change that.
Yes.
Previous upward up ऊपर हाँ यहाँ पे भी है so allocate this in 50W real
Ah,
हाँ
yes. Okay.
so it allocate the 3D array
Yeah, yeah.
now check that book what are the functions we got so we have to numerical recipe
Yes, sir. Column.
yeah just yeah so we have float triple data we have done that
Hmm.
next is float double array sped QP
Hmm.
so we have to allocate this 2D array okay so I think that there is a function for allocating 2D array
Okay, sir.
yeah before that float allocate float 2D
Uh,
yeah, it's written here
okay, yeah, got it. Yeah, yeah, this one. Yeah.
so just here to just write this yeah setting of memory for row you just in that function only you just include and make
Okay,
it
sir.
global
Yeah. What should I include? Should I allocate it?
yeah just write any name yes just write that name only
Yeah.
allocate just check what is the name of the function
Yeah, yes, it is. Allocate float 2D. Should
Static
it be
float,
static? Yeah, static.
double star.
Yeah, yes.
Actually, if you don't want static, is not also needed also.
Okay, sir. Yes.
So N1, N2, N3 is there. So it's
Yeah.
okay. So just go to that function, allocate 3D array. We have to give the size
Yes.
in the bracket.
Here.
No, not here. Go down. Yeah. Up. ऊपर.
ये
हाँ.
इसमें हाँ
ब्रैकेट के अंदर
यहाँ पे
allocate float 2D array के अंदर
हाँ
ऊपर
ठीक
वाला.
है सर हाँ
So एक्चुअली वहाँ पर देखो क्या क्या दिया हुआ है.
long and one or intent
Not if it is PDF numerical recipe. So it's 1 to NN1 and 1 to 2 NN2. It's in the fourth line.
yes sir
So just NN1 and 2 NN2.
यहाँ पे
हाँ. NN1 नहीं N1 capital N.
ठीक
2 N2. Not
मतलब
2 into N2.
okay 2
हाँ,
into yeah
Okay. Good. Now we have to go to get file. Below that, get file 6.50.
सर कौन सा
नीचे है ना.
सर get file ठीक है सर हाँ get file हाँ
So just
इसका नेम चेंज हाँ
just
यहाँ
remove the FFTW complex. Remove कर दो
हम्म
पूरा.
क्या यूज करना है सर
उसे यूज नहीं करना है, काट दो.
ठीक है पूरा रिमूव कर दो
हाँ.
ठीक है सर और
ये सब एक काम करो, बीच पहले लिख लेते उसका डिलीट करना. ठीक है.
सर
We'll first write the function, after that we'll delete everything.
ठीक है सर तो अभी क्या करना
So just after float hf,
हम्म
after that
ठीक
line,
हम्म
just call that function rffTW3. Just check. No, what are not rffTW, that we
हाँ
have
सर
copied.
RLFT3
This one rlft3. ro this
सर
ro,
हाँ
then your this
भाई
sped.
हाँ
हाँ.
SP
Then n1 n2 n3, capital N1. Comma 1.
ठीक है सर
So हो गया. So
सर इन दोनों का क्या करूं?
हाँ
ये नेक्स्ट 2 लाइंस की क्या करूं सर?
हाँ वो आएगा। तो उसमें आउटपुट किसमें प्रिंट कर चेक कर एक बार, इस कॉम्प्लेक्स एरे के बदले क्या लिखना है।
ठीक है, मैं तो कंपाइल करके देखता हूँ।
कंपाइल करके चलेगा नहीं।
प्रिंट कैसे करूं सर?
इधर न्यूमेरिकल रेसिपी फंक्शन पे चलेगा।
हाँ ठीक है।
Just check where the output will be printed in which function. Just that is this description. ऊपर ऊपर ऊपर। हाँ
जी
यहाँ
सर।
पर चेक कर ऊपर के।
सी टेक्स्ट।
ऊपर नहीं उतने उसमें लिखा हुआ रहता है। हाँ this small इसमें the output data. So it will contains in the output data only.
हाँ सर।
Actually I can't see the book.
मतलब स्क्रीनशॉट नहीं हो रहा क्या सर?
छोटा छोटा दिख रहा है।
ओके सर। चल अभी।
हाँ Actually takes one parent one small for the case of large. Find the complex. Okay, just go down.
Sir, 1 minute sir, my battery is dying, so I send the
Huh?
code and PDF. My battery is dying sir, laptop battery.
Okay, okay,
So
okay.
I send the code to Deepak and even the PDF also. He'll continue with the screen share.
Sure.
Okay sir. Yeah, Deepak, it's visible.
So Deepak's screen is getting crashed actually. So we are trying. So we can resume.
Yeah.
No, Deepak, it's not visible. So is anyone possible to share the screen now?
Hi. Okay. Just go to page number 530 of numerical recipe book.
Sir, it is here. Yeah.
So on that page, they have got some examples of using RLFT3. So just use that like. Actually, it's not. Actually, nothing is showing in my screen. It's a black. It's showing Deepak has started screen sharing.
So like, but we can actually see it, sir.
Okay, do one thing. I think that everybody has got the code and this numerical recipe book. So let's try together. So we have got all the function needed, and most of the. So I think that this FFTW has been written in this page 530. 531 of this numerical recipe book. So let's try everyone. Let's try to do, if you can run that code. The target is to run that code that I have sent by changing this 52 double function. So I told you where to change that function. So let's see we can do that or not.
आ रहा हूँ मैं, जरा 5 मिनट दे। Hello.
Hello.
Yes, sir. Actually, I'm seeing that I'm having a lot of technical issue, and at the same time, even you are not able to present your screen. So I was suggesting maybe if you could just tell us what all things we are supposed to do. We'll try to do it on our own, and
Yeah, actually, I
then maybe
told
we
you
could.
that I've told you.
Okay.
Just you have
Sir,
to
we,
all the
we
functions have been written.
yes,
Yeah.
Yeah. So
sir.
you have to just edit that get5 function. This del square phi we have got this what we have read that this RO function. From that we'll convert that to Fourier space using this RLFT3, and Fourier space will do the operation that similar operation as in that function written, like instead of complex that will be different, something like that. Okay,
Okay. Yes, sir.
so only the thing is that you have to just edit. I have sent you the code that has been written in F50W3. So you have to edit that part, this get5 part, for this numerical recipe code. Only that. After you just run the code, if the code runs, you'll get the output, required output, nothing else.
Yes, sir. Okay. So basically, like the F50W3 for the program that you have written. I mean, the program that you have written is in F50W3, right? So
Yeah,
yeah, I mean, I'm not exactly getting.
F50W2.
Repeat it.
Actually, the code which I have sent you, this body dot, I have written that code in F50W2. So F50W2 is
Okay.
not been installed. There is some problem with you. So you have to change that F50W part with the numerical recipe part. That
Okay.
I think Aditya has just done that. He has
Yeah.
copied that function, yeah, and then copied some of the change some of the functions. So just you have to edit that, and most of the thing has to be done in get5 6.fda in that function.
Actually, the changes that Aditya made, he sent me the entire .c file,
Yeah,
and then I tried running it. After the compilation, there were like lots of errors in the.
actually he has not
Yeah.
completed that changes.
Okay. Okay.
So you have to complete that changes. So all the changes will come in this get5 6.fda.
All right. So I'll do one thing. I'll share that new nbody C file, and
Yeah.
I'll mail it to everyone so that everyone can then carry on from where they left, and hopefully they can work it out somehow.
Yeah, that's what I was telling. So just all of you just try it out. So you have to only change this get5 6.fda. So and what changes you have to do, you will get in this 530 page of this PDF.
Yeah.
Okay, sir.
So there they have got sample code. So how to use this RLFF FT3. So just understand that part and then make the required changes in this get5 6.fda. So that will make your code complete using Fourier transform of the numerical recipe book. After that, if you just run the code, it will work. So I think I have sent you that input file also, no? Output.gel.dat.
Yes, sir, we have mailed to all the participants.
Yeah. So everybody got that will be the input file. So in the starting, put that file in the same folder and just run the code. It will produce two output files. So output.fin.dat and another is output.xy. So output.fin.dat will be your output file. So you can plot it in the GNU plot as similar I've shown you, uh, shown by. So just plot that. That will be your required output. So this is what you have to do only. You have to change this. Do one thing. I think that I have to sign the certificates also, na?
Yes, sir. Like, sir, we will be sending you the certificates in a day or two.
Yeah, it's okay. So actually, it will take actually 2-3 days to fix my laptop also. So after fixing the laptop, I'll just send you the money. You send me,
Yeah,
but
yeah, I
when
got it, yeah.
if I send you the certificate, after you send me certificate, so hopefully I'll send you by Sunday or Monday. So it will be okay, na?
Yeah, that won't be a problem at all, sir. It's fine.
Okay, that's good. So another thing is that if possible, if you people are interested, then you just try the code and send me the code. If you have any problem, discuss with me with WhatsApp or mail.
Okay, after making all the changes.
Yeah, if suppose that
Yeah.
you have some doubt in understanding any of the part of the code or something like that, you just mail me or WhatsApp me, then we can clarify the doubts. Okay,
Okay.
it's not a
Yes,
big
sir.
deal.
Sure. Yes.
So actually, it's a problem with money. It's a bad luck for me only. Ki actually, I've seen that laptop at 3 o'clock is working. So when I switch on my laptop at 4:30, so it crashes. Neither the Windows is working nor the Linux is working. So some problem with the hardware only, hardware part. So I think I will fix it by 2 days. It will take 2 days. So better. And you people have helped me to complete this site. So better just try the code. So if you have time today, then you can try it today or tomorrow, anytime you can try. So we can have the this weekend up to Sunday we can have. We just try the code. If you have got any doubts or if you find it difficult to do, just contact me through email or this WhatsApp. I'll just try to clear your doubts. Okay. Any
Okay, sir.
problem?
Okay, sir. Okay, sir. No problem.
No problem. Okay, so that will be better, I think. Instead of I'm doing nothing actually, just guiding you. So it's better you just try it out. So you just I tell you, you have to just edit the code in Gate 5 6.fda. Okay, this function only you have to edit.
Sir, could you please write that file name in the chat?
Yeah, sure. Okay.
Yes, sir.
Just edit that part. Just include that if a Fourier transform. You have to only include that Fourier transform, and then everything will be set.
Okay, so guys,
Actually, this is the
yes, sir, please.
yeah. This is the basic particle mesh code. So here we have not included like how we can test that if our output is correct or not. So all this we have not done. So if you want to include that also, then this requires a little bit more depth. So this is the basic particle mesh code. So what we are doing. So you can include a lot of things.
Okay. So if there are any questions, guys, you can put it forward now, or you can drop them in the chat box.
Actually, most of the participants had got bored because of this.
So actually, even I am having some technical issues from my side as well. I mean, my laptop wasn't working. Like it has been almost a week or so, and
Yeah.
I was using my dad's PC, and it has got just 2 GB RAM. So every time I started sharing the screen, the web page crashed,
So you have
and
Windows
I was
XP
not
or
able to.
something.
So it's Windows 7. I mean, on 2
Therefore, it's
RAM,
getting
you
problem.
can't much. Yeah. So I think like anyhow like I guess now that you have told us almost everything that we are supposed to do about the program, I guess students can work it out themselves. And if you've got any doubts, as Dr. Prakash said, that you can contact him. You can also connect with him on WhatsApp. Uh, yeah, we will also send you the contact number and mail ID for to Dr. Prakash. I will share his email ID with you, and that way you can connect with him, and just try to debug or troubleshoot your codes so that you can have a fully functioning end body
Yeah,
simulation
it's
code.
better. Actually, if you do it yourself, then you'll learn a lot of things. It won't
Yeah.
be a problem. And it's fun also to do that. Like edit someone else's code.
Uh, mostly every semester whenever there's a new computational course, it can be either Fortran or Octave or anything. Well, I do the similar thing. I'll just start googling things like how do you do this, is there a syntax for the loop or anything. I'll just google
Yeah.
it and then I'll try to work it on my own. So actually that has a lot of new things to learn.
Actually, this Googling has been done by everybody. Actually, we also do that. First we
Yeah.
Google it. If you don't find it, then we start writing it.
Yes.
Yes, sir.
All the students, all the learners have the same problem.
Exactly. Okay, I see the chat window is empty, and since there are no questions, so I guess we can call it off now. So
Yeah.
I would really like to thank Dr. Prakash sir for you know trying to give out his precious time to us and help us with the simulation. Although it's due to some technical errors, it couldn't work out. But anyways, the best part is uh, there was there were many new things to learn. So I hope you guys also learned new things. And as I said, we'll mail the n body file and the this. You can just take a note of that. Get 56.fda, right? The changes from where it is to be made.
You
And at
can
the same
write in your this highlight that function actually. Just put that function in the last. Told them to change the last function. Just
yeah. So I think we can call it off now.
yes.
Yeah. So thank you for your time, and thank you participants. Apart
Thank you
from
for patience.
no, so it's just that technical, like all the technical things actually require a lot of patience.
Yeah.
That's
Actually,
Yes,
it
sir.
will be better. It would have been better if you have done it in the offline mode,
Linux.
like
Okay,
yeah,
okay,
Yes,
one
sir.
yeah,
one
It
week.
has been more better, I think.
yeah.
Yeah.
That
Actually,
I
if,
mean,
when I was in NIT Jamshedpur, so I used to take computational classes. So there we used to sit there and do some steps. So better, I've explained that thing in VIT, this fellow, Bhopal.
okay.
So I was there. So I used to take computational classes for BTech students. So computer science students have that course. So we used to sit there. So our class was 1.5 hours. So I think I find that we have sat there up to 6-7 hours continuously. All students are doing all their stuffs. So no extra
Yeah,
attendance
because that's
also.
offline.
Yeah. So they find it interesting, and that's challenging also. So they have little bit competition. So we have to do this fast compared to our friends like that.
Yeah.
So it's competing, and everybody used to do that. So that's much more actually good for me also actually. So that it's seeing students finding it interesting for doing the computational classes and everything.
Yeah. I mean,
Anyway, it
best part,
didn't work out here because of a lot of things.
yeah. Anyway, like the best part of offline thing is that you can have extended sessions. Like you can, as you said, like you can sit for 6 to 7 hours. You can have
Yeah,
breaks in between, but it's not feasible on the online mode. Sitting in front
offline
of the
it's
screen is not really working.
actually
Interaction
the
will be
problem
also
is
good,
that
sir, in that offline.
yeah,
Mainly interaction needs, no, sir, in the meeting or the
Yeah,
in
exactly.
person.
yeah. Anyway,
In the
if Corona permits, then we can have some on offline classes also. No problem.
if
It
it
all depends
permits,
on
sir, there
Corona.
mostly I think no chance of it.
Anyway, actually, I think that after some time the Corona will be like our cough and cold. Every year it will come and go. So hopefully in future we'll have some offline classes. Actually,
Sure, sir.
previously I think that I was told that I have to take some MAPL, this MAPL class,
Yes,
not
sir.
MAPL, Mathematica classes,
Yeah.
workshop on Mathematica. So after that, suddenly he told me that uh, it's better for in-body simulation. So actually, I didn't plan that you require some basic knowledge of these simulations. So, cause you require some cosmology.
Yeah.
So that's go a little bit odd. So hopefully, it's my new uh, what to say learning for me also that planning the courses based on the audience.
Yeah. I think N-body, the topic that we chose was a little too high for us.
Yeah, it's little too high. Actually, I also thought that after I start preparing, I thought that how can I tell you about this? Most of the thing you require some basic knowledge. Like programming is okay. Actually, uh, BTech also, BTech mean computer science also never do this in-body simulations in their 4 years actually.
Okay. Yeah.
And you're a physicist, so I don't know.
Yeah.
Anyway, it's good. I hope that you learned something from this simulation workshop.
Yes, sir. Yes,
Anyway,
we
anytime if you have, what I can say that anytime if you have any doubt or something regarding this, if you consider that asking anything to me, then you can just drop a mail or just WhatsApp me. Just tell that I am from here and this is my doubt. Just if I know that if I can clear that doubt, I'll clear for you. But I don't
sir, we
know.
can
If I
ask
don't know,
any
I'll tell
other
you.
topic. Means if you have any
Uh,
doubt in the programming like this.
yeah, you can ask me.
Yeah, thank you.
Actually, you can ask me anything. If I know